Hey everyone, my name is Dr. Clayton Miller. I'm an assistant professor at the National University of Singapore in the School of Design and Environment. I'm here to motivate you to take part in this edX course, Introduction to Data Science for the Built Environment. This course is designed for professionals in the building industry, including architects, engineers, contractors, manufacturers, operations professionals, and even occupants. I'm on a mission to teach modern data science skills to anyone involved in this industry. We have an extraordinary amount of data being created in our field, and my goal is to help reduce the fear someone gets in the face of large, messy data from buildings. Let's start out with how we already analyze data in the built environment. What are the tools that we use? Well, obviously the first one that comes to mind is a spreadsheet. I'm an engineer, I love spreadsheets. I'm sure you do too, or you wouldn't be taking this course. Spreadsheets have a lot of benefits. They're extremely easy to use. Essentially, they're just a two-dimensional grid of cells that you can type information into, create formulas, and do other simple calculations. Plus, everyone uses spreadsheets. You can send one to a colleague, and there's little learning curve for them to use it. But there are some problems with spreadsheets, which are becoming more apparent as we use larger amounts of data in the built environment. The first problem is that spreadsheets are not reproducible. Many of us have a story of someone sending us a spreadsheet in which we don't recognize the process used to get from raw data to finished analysis. We basically have to reverse engineer what steps that person took to really understand what went into that particular analysis. The second big problem is that spreadsheets don't handle certain types of data very well. The biggest example in buildings is sensor data. Building management system data, for example, has timestamps that are really difficult to analyze, merge, or change frequency in a spreadsheet. Last but not least, spreadsheets are not really designed for modern machine learning methods. In order for someone to really dive into data science, they need to understand how the power of prediction can be used. Spreadsheets are not the best tool for exploring these methods. At the end of the day, our spreadsheets are a little bit lonely, and there's a lot of pressure on them to meet all of our analysis needs. The main focus of this edX course is to give you another set of data science tools that are modern options to supplement spreadsheets. We essentially want to give our spreadsheet a friend. And in this course, we're going to use an analysis tool called Python. Python is a modern, high-level programming language that's being used by millions of people around the world. It's a relatively easy-to-use programming language, which is very good for beginners. Python, because of its use as a data science tool, has exploded in popularity over the last 10 years. This chart from a website called stackoverflow.com shows how Python has surpassed all other programming languages that are commonly used in high-income countries. This means that there's a lot of demand for Python skills and also a growing amount of instructional content online, specifically catering to different types of disciplines. The main purpose of this course is to not make you into a software developer or computer scientist. The idea is that we're going to add basic data science skills using Python to your current building industry skill set or workflow. The goal is to take certain chunks of your usual workflow in which you previously used something like a spreadsheet, and we're going to add programming skills to automate and enhance that process. This gives you the ability to tackle larger and more diverse types of data. Why is data science important for the built environment? Well, it's because the building and construction industry does a pretty terrible job when it comes to efficiency. This graphic is from an article in The Economist focused on how the efficiency in various industrial sectors has changed over the last 50 years. It shows the agriculture, manufacturing, and retail industries and how their overall per-hour efficiency has skyrocketed, almost exponentially in some cases, while the construction industry peaked in the late 60s and has gone down ever since, back to its baseline in 1947. Why is this? Why do we have such a challenge in the building industry in terms of efficiency? When it comes to data in the building industry, I believe that there's a key challenge that we have to overcome. I call this the inconvenient data truth of the built environment. This truth is that all building designs are different. They're all one-of-a-kind prototypes. You have a different team of architects, engineers, and contractors who are designing, constructing, and operating buildings in completely different ways. Our industry can't achieve the same economies of scale that occur in other industries like manufacturing when each of our products is completely different. So as building professionals, we need to develop skills that are able to adapt and analyze data sets from different sources. This means that ad hoc analysis is more crucial to us in the built environment. Throughout this course, I will cover a few different areas related to data science and the built environment. The first goal is to introduce the Python programming language for data science in general. I'll show you some of the tools that are available and show you how to apply those tools to the different phases of the built environment process. I'll cover the application to design, construction, and operations through these individual workflows from each of these phases. Throughout these steps, I'll be talking about real case studies and how to integrate these workflows into these case studies for each phase of the built environment process.